Another way of solving the system is using the Gauss-Jordan elimination. If we put the augmented matrix of a linear system in reduced row echelon form or RREF, then we don't need to box substitute to solve the system. So here is our illustrative example. Same example in our previous solution in Gaussian eliminations. You have there 4x plus 8y minus 4z equals 4, 3x plus 8y plus 5z equals negative 11, and negative 2x plus y plus 12z equals negative 17. And our goal in Gauss-Jordan elimination is to make the augmented matrix into this format. The reduced row echelon form in the form of 1, 0, 0, 0, 1, 0, or 0, 0, 1, or which is actually an identity matrix. Since we already solved the system using the Gaussian elimination, okay, this was the last part of our solutions before we get into the box substitution. So we are going to utilize this information here, the row echelon form, to convert this one into reduced row echelon form. The row echelon form or REF will convert this one into reduced row echelon form for us to find the value of x, y, and z without using the box substitutions, meaning we just need to continue the process of solving the matrix. Okay, so then since we need to make our upper entry of the matrix become 0 there, then first here in the second column we still have positive 2. We'll make this one into 0. And how to do that? Again, we'll make an elementary row operation. So for row 1, r sub 1 minus 2r sub 2, and this implies r sub 1. We'll put the entry of the results in r sub 1. So then that will give us, in row 1, it's all affected. So r sub 1 will start with 1. 1 minus 2 times r sub 2 is 0. That will give us still 1. So we'll just write here 1. And then next entry, which is 2. 2 minus 2 times 1 is equals to 0. So that's it, no? We meet our goal to make it into 0. And then negative 1 minus 2 times 4 in r sub 2, then will give us negative 9. So we'll put here negative 9. Okay. And then the last part, 1 minus 2, r sub 2 is negative 7. And that will give us 1 plus 14 is 50. So that will give us positive 50. Okay. So we'll just copy the entries of row 2 and row 3. There. Okay, the next step is to make this entry here equals 0. We need to make an elementary row operations to make it into 0. We'll use the leading coefficient 1 in this column. So that means that our r sub 1 or row 1 plus 9 r sub 3, and we'll put the entry in r sub 1. Okay, so since r sub 1 is negative 9, then plus 9 times 1, of course 9, and it will give us 0. That's our goal in making the elementary row operation. And then in row 2, that would be r sub 2 minus 4 r sub 3, and we'll put the entry in r sub 2. There. 1 plus 9 times, and r sub 3 is 0 in this column. So you have there times 0, and that will give us 1. So we will write here 1. And then next entry is 0. 0 plus 9 times 0 in row 3, and that will give us 0. So here still 0. And the next entry is negative 9 plus 9 times 1 is equals to 0. Then next entry is 15 plus 9 times, here is negative 2 in this column, negative 2 in row 3, and then this will give us 15 minus 18 will give us negative 3. There. So here is negative 3. R sub 2 start with 0. This entry here, 0 minus 4. Okay, take note. We are here now in this operation. It's 0 minus 4 r sub 3, which is also 0. And that will give us 0. So here, entry is 0. Next is 1 minus 4 times 0 will give us 1. So next entry is 1. And the next entry is 4 minus 4 times r sub 3 in this column is 1. And that will give us 0. Okay, 4 minus 4 is 0. And that's our goal in making that elementary row operation. The next entry is negative 7 minus 4 times the entry in row 3, which is negative 2. So we'll multiply it by negative 2. And that will give us negative 7 plus 8, because negative 4 times negative 2 is positive 8. Negative 7 plus 8 is 1. And here, that be 1. And then the last row, row 3, since we did not make any elementary row operations, we'll just copy. Okay? In this format, this is now the reduced row echelon form, in which we can find our x and y values in the last column. So you have there 1, 0, 0, and 0, 1, 0, 0, 0, 1. And in the last column, it's negative 3, positive 1, and negative 2. And suppose that's our values of x, y, and z. So this is our x, this is our y, and this is our z. So it follows that our x is equals to negative 3, our y is equals to positive 1 there, and z is equals to negative 2. So then the order triple, we can write negative 3, positive 1, and negative 2, which is also the same answer in our solutions earlier using the Gaussian eliminations. So that's it about the Gaussian eliminations and Gauss-Jordan elimination. Remember that in Gaussian elimination, we just need to get the REF and then back substitute since we already have the value of Z. But in Gauss-Jordan elimination, we need to continue to reduce row echelon form, and then directly we can have the values of our x, y, and z in the last column here, negative 3, 1, and negative 2.